So finding the missing dimensions, let's look at A here first. A, of course, is vertical if I had drawn this well. It's a vertical dimension, which means we can only use other vertical dimensions to find it. So what other dimensions are vertical? The 6.5, the 4 3/5. So now we know that there are things that are constant. The length of this side of the rectangle, and if I draw a rectangle here, that length would have to be the same. Well, in this little rectangle, this length here and this length here would have to be the same. So this has to be 4 3/5. So then that 4 3/5 and A must add up to the 6.5. So how do we find A? Perfect. 6.5 minus 4 3/5, which gives us 1 9/10. B then, same type of thing. We know that this distance here and this distance here has to be the same. So this total distance here in green has to be 8 1/4. But then we also know this distance here and this distance here have to be the same. This is 3 5/8. So 3 5/8 plus B has to be 8 1/4. That's going to be 8 1/4 minus 3 5/8, which is going to give us what? 4 5/8, right? Yeah, I just wanted the dimensions. Okay, so that skill, by the way, when you guys deal with print reading and stuff like that, finding missing dimensions like that, I think I mentioned it before, it is one of the skills that students tend to really struggle with. So if you have any questions on that, this one was pretty straightforward. Where it gets to be more complicated, if you have something like this. And I'm just going to give you 10 3/4, 8 1/8, 2 3/4 here. This is going to be 1 7/8 here. 3 1/5. We're going to make this one 2 5/8 and 11 5/8 here. And if I ask you to find this one right here, we know that it's horizontal. So I'm only going to use other horizontal dimensions. So those 3 other dimensions are the only ones I can use. So I want to make rectangles with horizontal sides. So I'm going to cut this across here and across here. And the reason I'm doing that is now here, this is a rectangle. And we know that in a rectangle, opposite sides are the same length. So if this side's 8 1/8, this side's 8 1/8. Now from that, I'm going to look at this rectangle down here. That rectangle, of course, this side and this side would have to be the same. I can find this side by the 8 1/8 minus 2 3/4, which is going to give us 5 3/8, right? So this is 5 3/8. If you calculate it out, it'll come to that. Trust me. And then finally, we're down here to this rectangle, where if this is 11 5/8, this has to be 11 5/8. So you've got the 5 3/8 and A have to add to 11 5/8. So we subtract 11 5/8 minus 5 3/8, 6 1/4, 6 1/4. So it's all, finding the rectangles, finding missing sides, and comparing. Notice here, I did not use any of these dimensions. The reason I didn't use them is they were vertical. The dimension I was looking for was horizontal. Some people can look at a drawing like this and just see those missing pieces and see how they have to fit together. Others really struggle. I mean, another way that I've showed some of you on one of the quizzes is to set a zero line and to find distances from the zero line. Some people think that way. So there are several different ways you can break these down. If you're struggling with it, come talk to me or talk to Richard so that we can get, help you figure out how to break them down to find those missing dimensions. Like I said, that is a skill that is vitally important, but I know a lot of people do struggle with it. You may have any questions? We didn't have any homework yesterday, did we? So that means we can jump right. Like I said, some of you are still working on the quiz, and that's fine. If you want to set it aside for a while, we're going to take a look at some new stuff here. So we went over how decimals work a little bit yesterday. Today we want to go over the operations quick. Now when we add or subtract numbers, remember the first thing is need the same name. With whole numbers, that came down to whether they were inches or feet or pounds or whatever, or it even came right down to the place values of each digit having to be the same to combine them. For fractions, the same name meant common denominator. Now we're always going to combine the counts no matter what operation we're doing, but when we add or subtract, we then keep the same name. For decimals, to make sure they have the same name when we add and subtract, (17.32 plus 19.8). When I set this up, what would I have to be sure to do? Line up the decimal points. Lining up those decimal points is just making sure that ones get combined with ones and tenths get combined with tenths, and so on. Now I should fill in this missing zero here. And now I'll go ahead and add. 2 plus 0 is 2. 3 plus 8 is 11. So I have 1, carry the 1. Notice the decimal point does not affect my carrying at all. Now before I do that next column, what should I do? Bring the decimal point straight down. Bringing that decimal point straight down is keeping the same name. The tenths stayed tenths. The ones are going to stay ones. 1 and 7 is 8 plus 9 is 17. So again, we keep the 7, carry the 1. 1 and 1 is 2. So 27.12. When we subtract, if I have a problem like, come on, there it goes. Let's say I have a problem like 18.3 minus 7.48. Again, when I set this up, I have to make sure I line up the decimal point. Now here I definitely have to fill in that missing decimal place with a 0. When I go to subtract, 0 minus 8, of course, can't be done, so I need to borrow. So the 3 becomes a 2, this 0 becomes 10. 10 minus 8, 2. 2 minus 4, we're going to borrow from the 8. That's a 7, and this is a 12. Notice the decimal point did not affect our borrowing at all either. 12 minus 4 is 8. We do have to bring down the decimal point. We can't cross the decimal point when we add or subtract without bringing it down, without doing something with it. 7 minus 7, 0, and 1 minus nothing is 1. So 10.82. Now there is an example I do want to show you with subtraction. An example that looks something like this. (8 minus 2.3794). I have to line up my decimal point. Where is the decimal point in the 8? At the end of it. So now the the decimal point goes there. 3794. Do have to put in my zeros. I need 4 of them. Now I go to subtract here. 0 minus 4 Can't be done. So I got to borrow, but there's nothing here to borrow from. I have to go all the way to the 8. That's going to become a 7. That makes this a 10. But I need it all the way down here, so I have to do it over and over again. That becomes a 9, and now this is a 10. Borrow from the 10, that's a 9 and a 10. Borrow from the 10, 9, and now it's a 10. Now we can subtract. 10 minus 4, 6. 9 minus 9, 0. 9 minus 7, 2. 9 minus 3, 6. Decimal point comes down. 7 minus 2 is 5. There are a lot of shortcuts you may have been taught for doing that. If you have one that you remember and it works well, that's fine. But this is the long way, which isn't that bad, of doing that. Multiplication. So let's have 7.35 times 2.6. I just set it up vertically. Notice I did not line up the decimal point. When we multiply or divide, we do not need the same name. You are correct. And of course, we're going to combine the counts just like any other operation. But when we multiply or divide, we also combine the names. So when we multiply here, I got 6 times 5 is 30. So that's 0, there's a 3. 6 times 3, 18 plus 3 is 21. So 1, carry the 2. 6 times 7, 42 plus 2, 44. So 4, we carry the 4 over into the next place. Before I move over to the 2, put in a 0. I'm also going to put in a line up here. That helps me determine anything below the line is old carry. I don't need to worry about it anymore. 2 times 5, 10. So this is a 0. We carry the 1. 2 times 3, 6. The 1's above the line, so I know it's new. So it's 6 plus 1 is 7. 2 times 7, 14. There's nothing above the line, so it is just 14. So 4, carry over the 1. 0, 1. 4 and 7 is 11, so 1, carry the 1. 1, 4, 4 is 9, and 1. Where does my decimal point have to go? The 9 and the 1 after, right? How do I know that? Yeah, we count. There's 1, 2, 3 decimal places total in the problem. There has to be 1, 2, 3 decimal places in our answer. Now, I did this problem like this intentionally with these zeros here. A lot of people think, oh, a 0 at the end, I can just drop it. No, you can't. You got to keep it there until you locate the decimal point, because you got to count it as one of those. Second is when we talk about measurement in a few weeks, that is, if this is a measurement, that 0 is important. It may not have any numerical value, but it tells us something about the measurement. So if it's there, we need to know whether it's really there or if it's just sitting there to hold a place. Now, the whole counting decimal places here to get that many decimal places in your answer is the shortcut, the way of doing it. Of course, we know what's really happening is this is hundredths times tenths, better give us thousands. But remember, I also talked about on the first couple of days, before you punch it in the calculator, estimating. And I do realize that with decimals like this, they're really easy to put in the calculator, so you're probably going to do that. But stepping back and saying this is about 7, this is about 3. What's 7 times 3? 21. I'm expecting an answer close to 21. Would 1.9110 make any sense? No. Would 191.10 make any sense? No, it won't. So we know that the only place that decimal point can go that makes any sense is 19.11. Division. Well, just like the long division I showed you on the second day, the process of division with decimals is, again, one of the processes that has been mutilated the most. Remember that process I showed you where you did the place values times the number here and came up? Long division with decimals, would work exactly that same way. There's absolutely no modification for the decimals. But since that's not the way we've been taught anymore, they've had to modify it and do special things to make our shortcuts work with decimals. Let me show you what I mean. If we have something like, well, let's say 48.743 divided by 3.2. I'm going to ask for this to the nearest thousandth. How do we divide by a decimal? Well, the answer is we don't. How do we avoid dividing by a decimal? You've been taught to move it over, right? You move it over here to the end of the number you're dividing by. So in the number you're dividing, you move it over the same number of spots. Here there was one decimal place, so we moved it over one. Here we moved it over one. If there had been two decimal places here, we'd have to move it two, and so on. Why are we able to do that? Well, we mentioned a little bit, that's part of it, kind of. But we mentioned a little bit yesterday that a division problem can be thought of as a fraction, and a fraction can be thought of as a division problem. We think of this as a fraction. If I want to get the decimal point out of the denominator, I multiply by 10, right? 3.2 times 10 is 32. Well, if I multiply the denominator by 10, I have to multiply the numerator by 10. So that becomes 487.43. Is that the same fraction? Yeah, it's equivalent. It just looks different. So when I put it back in division, oops, 487.43 divided by 32, it's the same division problem. It just looks different. Like I said, if we did that long way that I showed you on the first couple of days, we don't need to move the decimal point. We can divide by 3.2 just fine. This is their shortcut for making it work. Does 32 go into 4? No, so we're going to leave it blank above the 4. 32 go into 48. It goes in there once. Now 8's the last digit we use, so the 1 goes above the 8. 1 times 32 is 32. We subtract, we got 16. We bring down the 7. Does 32 go into 167? 5 times. 5 times 32 is 160. There's 7 left. Before I can bring down the 4, what do I have to do? Move up the decimal point, yes. I bring down the 4. Does 32 go into 74? Twice. 2 times 32 is 64. So we got 10 left over. Bring down the 3. 32 into 103? That's 3 times. That would be 96 with 7 left over. Now, I'm out of numbers there, but I said to the nearest thousandth. So what can I do? I can add a 0 and bring it down. Does 32 go into 70? Yes, it goes in there twice. That would be 64. There's 6 left over. Now that's the thousandths place. Am I done? Say no. I've got to add one more 0 and bring it down. 32 goes into 60 only once. Why did we have to go that one extra place? Well, going to the nearest thousandths means we're going to round it. In order to round it, we have to have that next digit to see whether we round it down and leave that number the same, or whether we have to round it up to the next place value, or next digit. This comes into play when we were converting fractions into decimals. We had something like 5/8 to convert that into a decimal. It is 5 divided by 8. Now, when we look at this, 8 does not go into 5. So we're going to add the decimal point and add a 0. Now, before we can try 8 into 50, we have to move the decimal point up. 8 goes into 50 6 times. 6 times 8 is 48. There's 2 left. And we can keep adding zeros. 8 into 20, twice. 2 times 6 is 16. We've got the 4. Add another 0. Bring it down. 8 goes into 40, 5 times. So it ends right there. That's it. It's perfect. Nothing left over. Some of these, as we saw yesterday, will keep going. We'll have the repeating decimals. Some just keep going forever and never repeat. Those are always fun. If we can divide them out like this, by the way, they will either terminate, end like this one, or they will repeat. Because if it can be expressed as a fraction, it either repeats or terminates. For tomorrow, in the little book, units 11, 12, 13, and 14. Of course, the odds. Check those yourself again. And we'll discuss any questions you have on those tomorrow. I'll give you the last 7 minutes here. Go ahead and get started on those.